Assalamu alaikum everyone. In today's video, we'll be discussing the static electricity, which is the first chapter, which is the first subtopic of the chapter electricity. So let's get started. What is electrostatic? So electrostatic is the charge on electron. Electrostatic states that the charge on electron and charge on proton equals to 1.6 into 10 power 19. This is the charge on electron, and charge on electron and proton are equal. So E is for electron and P is for proton. Number of protons and number of electrons are equal. Then we then you should know that protons reside in nucleus, means protons are present in nucleus. Protons are in nucleus and they are positively charged. So proton have charge of positive, however the electrons have charge of negative, and neutrons and protons both reside in the nucleus, and when they both are together, proton and neutron, they are known as nucleon. Proton and neutron when are together in nucleus, they are known as nucleon. Okay. Then you should know that electron orbit around the nucleus. So electrons orbit around the nucleus. For example, this is the nucleus. Here are protons and neutrons. Neutrons are neutral, they have no charge, and the electron orbit around the nucleus. For example, this is a shell and this is an electron, and it orbit around the nucleus. Okay, the free electron is the electron which orbits in the outermost shell of the orbit of an atom and experience the least attractive force. So free electrons are those electrons that experience least attractive force due to which they roam around. So now let's move towards the next topic. Before this, you should know that when an atom gains an electron, so for example, any atom X gains electron, so it have a charge of negative, and when any atom loses electron, so it have a charge of positive. Positive in case of lose electron and negative in case of gain electron. Then let's move towards the second topic. Before this, you should know that the deficiency of electron results in positive charge because, for example, this atom X loses one electron, or you can say loses two electron. So electron get less. There is deficiency of electron, so it gets positive charge. However, this electron X when gains electron, so it have X's electron, it results in a negative charge. Then let's move towards the second thing, which is imbalance of electron results in, let me write it, imbalance of electron result in static electricity. Imbalance of electron results in static electricity. Okay, so deficiency of electron results in positive charge, excess of electron results in negative charge, and imbalance of electron results in static electricity. Then you should know the laws of electrostatic. So laws of electrostatic. So there are two laws of electrostatic. First one is that like charges repel each other. Like charges repel each other. And the second law is that unlike charges attract each other. Unlike charges. Okay, so these were the two laws of electrostatic. Then the second thing you need to know that how to charge and insulate. How to charge an insulator. So firstly, due to the imbalance of electron, a body becomes charged. When the body becomes charged, or you can say that insulators are charged by rubbing, friction, or rubbing. So these are the two methods to charge an insulator. When two bodies are rubbed, one body gains electron and becomes negatively charged, while the other body loses electron and become positively charged. So let me write it here that insulators are charged by rubbing, or you can say friction. When two bodies are rubbed, one body gains. I'm adding electron in short form E negative and becomes negatively charged, while the other body loses electron and become positively charged. This positively, I've written it in short form. Okay. So insulators are charged by rubbing, or you can say friction. When the two bodies are rubbed, one loses electron and become negatively charged, while other gains electron and become positively charged. So here is an example to explain you this. For example, this is a glass rod and it have electron positive and protons and electrons both. Then we have a duster. For example, this is a duster. So it also have positive and negative electrons and protons. Okay, when these two things are rubbed together, this is a duster and this is a glass rod. When they both are rubbed, so after rubbing, the glass rod gains electron while the duster loses electron. So proton will never be more, but the electron, you can say the electron concentration can be changed. Means you can gain or lose electron, but the proton will remain same. Okay, let's move towards the second topic of this of the same chapter, which is charge. So the symbol for charge is Q. Q is the symbol for charge and its SI unit is coulomb. So you can say capital C or coulomb. Then the formula to find the charge is Q equals to current into time. I is current and T is time in seconds, and current is in amperes. Current is in amperes, current as a unit, and time is in seconds. So you can remember this formula using a triangle. So this triangle is like this. Q is a top and I into T. So this line is the sign of multiplication, and this line is the sign of, you can say, division. When you put your finger at Q, you need to find Q, means charge. So you have to multiply current into time. And when you put your finger on time, you have to find time. For example, you have to find time. So charge divided by current. So you can rearrange this formula to find time, current, or charge. Then you should know that what is earthing or discharging. So it is the removal of the charge. Earthing. Firstly, you should know the sign, or you can say the symbol of the earthing. So this is the symbol of earthing, or this one. Both are same. You can remember any one of them. So it is the removal of charge. Removal of charge. For example, this is a sphere which have positive electrons. So when the sphere have positive electrons, here is the earthing wire, and the electrons move towards the sphere. So electron moves towards the sphere and makes positive charge neutral. When these electrons move towards the sphere, they make the positive charge neutral. And we have discharging of charge, in which, for example, this is a sphere with negative charge. Now the electrons are moving out. The direction of the electron is towards out. So such question can come in P1 in MCQ paper. Then, so for example, you have a sphere which have both positive and negative electrons. Then you have a rod, which is, this is a charged rod with negative electrons, with the positive electrons. Now when this charged rod is brought near to the sphere, so the redistribution of the electrons occurs because of the presence of the charged rod. When these electrons are redistributed, so now the sphere have, this is the glass rod, which has the positive charge, and this is the sphere. Now this time, when the redistribution of electron occurs, so negative electrons come towards the rod side. However, the positive electrons move away from the rod side. So you can see that here is the deficiency of electrons. However, are the here is the excess of electrons. Excess of electron. Okay. You should know that what is an electric field. So electric field is a region around a charge in which another charge experience force. So this region is known as electric field. Definition for 1 mark can come in P2 in part A of the question. So how to draw the electric field pattern? Drawing of electric field pattern may come in P2 and may come in P4 too. So to draw the electric field pattern, you need a test charge. A test charge is needed to draw the electric field pattern. So test charge is always positive. Now, to draw the electric field lines, you should remember some cases. The path on which the test charge accelerate is known as electric field line. So this is the definition of electric field line. It may come in MCQ paper in P12 and in P2. So the path on which test charge accelerate is called electric field line. So this is the definition of electric field line. The path on which the test charge accelerates is called electric field line. Test charge is used to draw the electric field, and test charge is always positive. Now here are some cases which you need to remember. First one is that when the charge is positive, so the lines would be going out. And the second thing you need to remember that whenever you have to draw this, so the number of arrows should be equal and opposite, like this. For example, you can use a scale and a pencil. You can keep the scale here, like this, and then draw the lines. This, this. So the lines should be, you can say, in the same line on the opposite side. Now you can rotate this scale to draw the other lines too. And the arrow would be pointing towards out. Then for the negative one, you have to do the same thing, but in negative charge, the lines would be coming towards the negative charge. And the lines should be equally drawn. I'm drawing it on the screen, so that's why they aren't equal, but you should draw the lines equal. You may use a scale, but you shouldn't draw the lines inside this circle or inside this charge. The line should be drawn outside the charge. Then for when there is a field line, a condition like this, the positive and the negative, both charges are present, and now you have to draw the electric field lines. So the positive will go towards the negative, like this. This is the first line. Then as I told you that in the positive lines are going away from this charge, and the negative lines are coming into the negative charge. So this was the negative charge. So the direction would be like this, from positive to negative, from positive to negative. And here the electric field line would be coming inside the charge like this, because this is the negative charge. So electric field lines are coming in. However, this is a positive charge, electric field lines are going out. So this is the electric field line for positive and negative charge together. When there are two different charges, they attract. When there are two same charges, for example, positive positive or negative negative, so what will happen? Let me draw it. They will repel. As a result, the field lines for positive will go out, and the field line, this is also positive, the charges are same, will also go out, and the field lines won't match. Like this, they will go out from the charge. Okay, then here is the case 5. In this, some, here is the positive, this is negative. Now the field lines would be going from positive to negative, and the field lines would have equal distance and should have equal length as well. So they should be equally spaced, and they should be straight. The lines, field lines should be straight in this case, and there should be the uniform electric field. Maybe my lines won't have the same space, but your line should be having the same space as you will be drawing it in on the paper. Then case 6 is that you have a charge, for example, positive charge, and here is the negative charge. Now the field line will go from positive to the negative charge here, and from positive it will go outwards, and it will go towards the negative charge. As field lines goes out from the positive charge and goes towards the negative charge. So these were the 6 cases which you need to remember for the electric field lines. This question may also appear in MCQ in P1. Now, few things that you need to remember. So the first one is that, let me draw it. This is a charge and it is written that it is uncharged and it is at rest. So which force, or you can say which force is acting on it. So right now only gravitational force is acting on it due to mass. It is uncharged and it is at rest, so gravitational force is acting due to mass. Then the second condition, this is uncharged and it is uncharged, but it is moving this time. It isn't at rest. This is moving. So this will also have only gravitational field due to mass. Then condition 3, in this you have a charged body this time. It have charges. This is a charged body, but it is at rest. So right now, electric field is electric field is present here because this body is charged. Electric field present, as well as gravitational field due to mass. Then the fourth condition. In this fourth condition, you have a charged body. This charged body is moving. It is charged and it is moving. Now, when it is charged and it is moving, a magnetic field is formed. Magnetic field formed and electric field formed, as well as gravitational field formed because it have mass. Due to mass, gravitational field is formed. Due to movement, due to charged body, electric field is formed, and due to movement with charged body, a magnetic field is formed. So if a body is massless, so it have no gravitational field. If the body is at rest, if the body is uncharged and is at rest, So it only has gravitational field due to its mass. And if the body is uncharged and it is moving, so it will also at just a point it will also have only gravitational field. But if it is charged and is at rest, so it will have electric field plus gravitational field. And if it is charged and is moving, it will have magnetic field, electric field, and gravitational. So I hope you understood these four cases. Thank you.